everyone, this is Mona Sheikha, and for today, in this video, I'm gonna share to you what I've learned about chemical bonding. So, let's get started. Before we proceed, may I ask to you, what do you know about chemical bonding? Chemical bonding is one of the most basic fundamentals of chemistry that explains other concepts such as molecules and reactions. Without it, scientists wouldn't be able to explain how atoms are attracted to each other or how products are formed after chemical reactions take place. To understand the concept of bonding, one must first know the basics behind the atomic structure. A common atom contains a nucleus composed of protons and neutrons with electrons in certain energy levels revolving around the nucleus. In this video, our main focus will be on these electrons, especially the valence electrons. So, what is valence electrons? Valence electrons are the electrons involved in forming bonds to form compounds. It is important that you know the valence electrons so that you can illustrate how the bonds are formed. The nature of the interaction between the atoms depends on the relative electronegativity. But what is electronegativity? Electronegativity is the measure of the tendency of an atom to attract electrons. So the higher its value, the higher its tendency to attract electrons. It is good that you have found out that metals have low electronegativity while nonmetals have high electronegativity, because this property plays an important role in forming compounds. So back to chemical bonds. Chemical bonds are forces that hold atoms together to make compounds or molecules. It is the connection between atoms in a molecule. Chemical bonds are formed when valence electrons, the electrons in the outermost electronic shell of an atom, interact. Shown on your screen is the periodic table representing the number of valence electrons. The alkaline metals of group 1A have one valence electron. The alkaline earth metals of group 2A have two valence electrons. Group 3A has three valence electrons, and so on. The non-indicated transition metals, lantanoids and actinoids, are more difficult in terms of distinguishing the number of valence electrons they have. However, our main focus is on bonding, hence they will not be covered in this video. Further on, most elements follow the octet rule in chemical bonding, which means that an element should have contact to 8 valence electrons in a bond or exactly fill up its valence shell. Having 8 valence electrons total ensures that the atom is stable. This is the reason why noble gases, a valence electron shell of 8 electrons except helium, are already stable and tend to not need the transfer of electrons when they are bonding with another atom in order to be stable. On the other hand, alkaline metals have a valence electron shell of 1 electron. Since they want to complete the octet rule, they simply lose 1 electron. This makes them quite reactive because they can easily donate this electron to other elements. This explains the highly reactive properties of group 1A elements. Chemical bonds include both strong intermolecular interactions such as ionic bonding and covalent bonding. What is ionic bonding? Ionic bonding is a process of not sharing valence electrons between two atoms. It occurs between a nonmetal and the metal. Ionic bonding is also known as a process of transferring the valence electrons to one another. Shown in your screen is a sodium atom and a chlorine atom that are being combined through ionic bonding. Sodium has less electronegativity. This will easily allow the more electronegative chlorine atom to gain the valence electron of sodium to complete its third energy level. Once the valence electrons have been transferred from the metal atom to the nonmetal, Both metal and nonmetal are considered to be ions. The metal that loses its valence electrons, such as sodium atom, will be positively charged and it's called cation, while the nonmetal who gains the valence electrons, such as chlorine atom, will be negatively charged and it's called anions. Remember, in ionic bonding, it is always the metals who loses or gives its valence electrons to nonmetals, while nonmetals is always the one who will gain the valence electrons from the metals. So, let's proceed to the other type of chemical bonds, which is the covalent bonding. So, what is covalent bonding? Covalent bonding is the process of sharing valence electrons between two atoms. The bonds are typically between a nonmetal and a nonmetal. The formation of covalent bond allows the nonmetals to obey the Alkaline rule and thus become more stable. There are two types of covalent bonds: the polar covalent bond and the nonpolar covalent bond. Polar covalent bonding is a process of unequal sharing of valence electrons. It is considered the middle ground between ionic bonding and covalent bonding. It happens due to the differing electronegativity values of the two atoms, while the nonpolar covalent bonding is a process of equal sharing of valence electrons. One way to figure out what type of bond a molecule has is by determining the difference of electronegativity values of the molecules. If the electronegativity difference is between 0.0 to 0.3, then it is a nonpolar covalent bond. If the electronegativity difference is between 0.3 to 1.7, then it is a polar covalent bond. If the electronegativity difference is between 1.7 or more, then it is an ionic bond. Shown is a table of difference of ionic and covalent bonds based on their properties. The types of atoms involved in ionic bonding are metals and nonmetals, while for covalent, it is nonmetals only. In terms of method of bond formation, for ionic, it is positive ions bonding with negative ions or transfer of electrons, while for covalent, it is sharing valence electrons. In terms of type of structure, ionic is crystalline, while covalent is molecular. In terms of physical state, whether it is solid, liquid, or gas, ionic is solid, while covalent can be gases, liquids, or low melting point solids. In terms of melting or boiling point, whether it is high or low, ionic has a high melting point, while covalent has a low melting point. In terms of solubility in water, ionic is soluble, while covalent can be insoluble or soluble. In terms of electrical conductivity, ionic is high as liquid but low in solid, while covalent does not conduct. In terms of other properties, ionic are mostly hard, while covalent are flammable. So, after I shared to you the lessons that I've learned about chemical bonding, let me give some examples to you of ionic, polar covalent, and nonpolar covalent bonding for you to fully understand about it. For ionic bonding, let's have sodium chloride. Sodium is a metal, while chlorine is a nonmetal. Sodium is in group 1A, which means sodium atom has one valence electron, while chlorine is in group 7A, which means chlorine atom has 7 valence electrons. To obey the Alkaline rule, sodium atom simply loses its one valence electron, while chlorine atom will gain this valence electron to become stable. The sodium atom will be positively charged and called cation, while chlorine will be negatively charged and called anion. To make sure, let's see their electronegativity difference. Sodium atom has a 0.93 electronegativity, while chlorine has a 3.16 electronegativity. If we subtract this, the electronegativity difference will be 2.23. As I said earlier, if the electronegativity difference is 1.7 or more, then it is an ionic bond. For polar covalent bond, let's have water or H2O. Both are nonmetals. Oxygen has 6 valence electrons, while hydrogen has only 1 electron. To obey the octet rule, there must be 2 hydrogen atoms to share the electrons to oxygen. So, in this case, there is no equal sharing of electrons. To make sure, let's see their electronegativity difference. Oxygen has 3.44 electronegativity, while hydrogen has 2.2 electronegativity. Then, if we subtract them, the electronegative difference is 1.24. As I've said earlier, if the electronegativity difference is 0.3 to 1.7, then it is a polar covalent bond. For nonpolar covalent bond, let's have 2 chlorine atoms. As you can see, they equally share their valence electrons. To make sure, let's see their electronegativity difference. Chlorine has a 3.16 electronegativity. So if we subtract the electronegativity of 2 chlorine atoms, the electronegativity difference will be 0.0. As what I've said earlier, if the electronegativity difference is 0.0 to 0.3, then it is a nonpolar covalent bond. So, that's it. I hope that this video helps you a lot to understand better the chemical bonds and its different types. Thank you for watching and have a great day.